Well, good morning, good afternoon, wherever you may be. Welcome to Zyxel's Tech Talk. My name is Tri Nguyen. I'm the Market Development Manager and Product Manager here at Zyxel North America. Glad to have you here this morning or afternoon and joining me to discuss about the importance of 10 gig and multi-gig that's happening, the transition that's happening because of probably things like Wi-Fi 7. That's probably the biggest generator of demand for this, as well as faster internet speeds and taking advantage of those things. And so we're going to be talking about that and covering it in today's topic. So if you'd like I like to make this interactive. So if you'd like to participate, please feel free to ask any questions in the Q&A section. It helps for me to manage it a bit better while we go through the topics at hand. And that way I can try to answer them in line with the presentation. So so then that way, we can have it, have some fun with that. And if you have any questions, of course, I will stop and answer those if it pertains to those slides. Let's go ahead and jump into the introductions of who Zyxel is if you don't know who Zyxel Networks is. So Zyxel Networks has been in business now, I think it's over 37 years because we've been founded in 1989. Over 100 million devices making connections worldwide, 650 employees serving in 150 different markets, and over 1 million businesses work smarter with Zyxel solutions today. We partner with other vendors and solutions to deliver connectivity to a lot of different kind of avenues, different partners here you can see that we provide networks for, but then we also work with industry leaders to provide different types of solutions, to provide you with multiple avenues to using not only their solutions, but also to enhance our products and our solutions as well. So some of these names that you see here are either integrated into the product or we have partnered with them to provide some sort of solution or a management solution, or even like pre-sales kind of scanning, like in the case of Ekahau for wireless. But then all of the other ones you see there for security functionality, those vendors provide us a lot of the key solutions and the key signatures for our products that we use in our security firewalls, et cetera. And we are solutions driven. So we work with clients like yourself to provide not only the products, but a complete solution for those applications. So we also have our large R&D resources and facilities around the world to help deliver these kinds of solutions. So you get that, that feel of the partner being able to provide us with feedback on how we can make your lives easier. How do you make your customers easier, or your day-to-day functionality, day-to-day monitoring of those different customers and solutions easier as well. So I wanted to jump into why multi-gig is important, or even 10 gig networks is important. It's all about the infrastructure, and it's 10 gig has been around for quite a while. And we haven't really seen a lot of that adoption in the small business side of things. We do see it in the enterprise level. But I think maybe the turning point on people moving to multi-gig and 10 gig networks is going to be pushed because of Wi-Fi 7, because of service providers also now being able to offer more than just a 1 gig connection in some places. We're going to see that kind of move that and transition customers into this space more so, right? The adoption of mobile devices having Wi-Fi 7 helps. So people who are connecting to these want to take advantage of the higher speeds and potential better quality wireless connectivity. So that's why I wanted to touch on this topic, because the Wi-Fi Alliance estimates that this year alone in 2026, over 1.1 billion Wi-Fi devices will enter the market, and it will grow. It will double basically in the next couple of years as well. Why is that so? Maybe because of the higher speeds, et cetera, is part of it, but also the bandwidth and the channels. Right now, we're saturated with 2.4 and 5 gig networks. Pretty much everybody has them at home. They have it in their offices. And if you're anywhere close to any other homes or offices, you'll see, anywhere between 5 to 40 SSIDs that are broadcasting signal, and pretty much causing a lot of noise and interference that's happening on the network. So Wi-Fi 7 does offer that extra channel band, that 6 gigahertz range. Not only is it better in terms of more channel space to use, but then it's at that higher speed as well. But I get the number one question I get is, well, why would a customer want to upgrade to Wi-Fi 7? Their internet connection maxes out at 1 gig. So they can't take advantage of potentially, 46 gigs that Wi-Fi 7 can operate at. If you buy the right products and you have the right number of antennas and radios, etc. But it can push potentially 46 gigs, which is more than 10 gig networks today. But that also is the theoretical max, right? So there is overhead in that. So the real throughput is, let's just say it's 10 gig. That's probably more realistic. Most people aren't going to have a 25 gig network, though we are seeing some of that in the space. But more so is the importance of this piece right here is MLO, the multi-link operation function that allows for you to use all three frequencies. And I'll talk a little bit more about that. But again, it's still that push of Wi-Fi 7 dictating the need for an infrastructure change, an infrastructure upgrade. I did see some other people who did show up a little bit later after I did the intro. But if you do have any questions or comments and thoughts, et cetera, and you want to interact with me during this webinar, please use the Q&A section so that you can ask your questions and I will answer those as we go along. So Wi-Fi 7 is that big push, right? You can see that in the technology space, not only does it give you more channels, it gives you more speed, but then it's important that you do get that 6 gigahertz range, but also the MLO is going to be that biggest piece. And why is that spectrum of the 6 gigahertz important? So 2.4 gig, it gives you, that 20 megahertz channel there, and then 5 gigahertz, you can split it up into more 20 megahertz channels. But you'll see the 6 gigahertz range, especially since we're not in the EU and we can you can utilize that whole space there. That whole spectrum is larger than 2.4 and 5 combined. So there's a lot of signal bandwidth that is probably clear, right? There's no other devices that are talking on it. And if there was, you could still find a space for it, a space that is untouched or with minimal interference. So that's super helpful to have that in your pocket so that you can push customers to those different channels. But the big one is going to be multi-link operation. In Wi-Fi 6, you can only communicate on one or the other, so 2.4 or 5 gigahertz. You have to pick one or the other. That's why everybody has like two SSIDs, one that says like dash 2.4 and one that says dash 5 gigahertz, just to make it clear and to understand which one you actually are connected to. But with Wi-Fi 7, there's multi-link operation, meaning it can talk on multiple channels and bandwidths at the same time. So you can talk on, if your client device supports it, you can communicate on 2.4, 5, and 6. So not only does that provide lower latency, it increases the data rate, but then it also makes it more reliable. And that's probably the number one big thing is the number one complaint about any kind of Wi-Fi connectivity is that it is terrible, or I don't get good quality signal, or I have a great signal, but I can't pass any traffic. It's probably because there's so much noise and interference. And so this will dynamically select the best links between the 2.4, 5, and 6, even on a packet level. So it transfers that data on what it needs across any of those channels that is open and clear at that point in time. So overall speed might not be the kind of the main selling point for customers, but the capability of multi-link operation to provide a much better Wi-Fi experience for client devices, that's going to be the big piece. And in order to use all those three channels, you have to have then multi-radio. You're pushing a lot more bandwidth, which is why then multi-gig and 10 gig networks is now a big importance in order to facilitate the bottleneck that potentially can exist right now if you only have gigabit connectivity or gigabit uplinks within your switches. Most of these Wi-Fi 7 products nowadays also include either like a 2.5 gig 5 gig or even a 10 gig port uplink in order to facilitate the throughput that it's capable of doing. So you don't want to bottleneck that while maintaining the technology that you want to take advantage of. So in order to take advantage of all this, you need to have all the radios turned on. Not only do you need the bandwidth, but then you also need the power. Maybe the existing infrastructure doesn't have a large enough power budget, or it's not doing the PoE injection intelligent enough that it runs out of budget to facilitate the power of these APs. So we're finding a lot of partners are going into the system and they want to put Wi-Fi 7, but then realizing the existing infrastructure, the old technology that might exist there, cannot facilitate to the full capacity or the full power of the devices. So they need to either add additional switches in order to facilitate that power, or they have to look at, kind of doing a refresh of the whole infrastructure to keep that up. So to understand a little bit more about how we name our switches here at Zyxel, let's just get a laser pointer out here. So we have some RG switches, which is our ruggedized switches. GS, if it starts with that, is our gigabit switch. Our MG switches are multi-gig switch. Our XGS, those are gigabit switches with 10 gig uplinks. So the X is just Roman numeral for 10. So you can now see XMG is a multi-gig switch with 10 gig uplinks. An XS switch, since there's no G, it is just a 10 gig switch. So it has all ports are either 10 gig copper or 10 gig fiber or mix and match. And then our new series name is called a CX switch. So it's the Roman numeral for 100. So it's a 10 gig / 25 gig switch with 100 gig uplinks. So you can see it's pretty easy if you kind of think about what how we follow the kind of this terminology to figure out what kind of switch it is pretty much off the bat. If it ends in HP, typically those are our PoE powered with standard power budgets. If it ends in an EP, there's more of like an economy or eco power budget. So it has a slightly smaller budget, for a kind of a mixed network, or maybe you're just using it for voice and you don't need a very large power budget. It's more cost effective there. And then there's an FP, which is like a full large power budget. They have typically extended power compared to the rest of that product series. And then if it just ends in a pure F, then they're typically fiber versions of the switch. So it has either they're primarily fiber connections and maybe some copper uplinks, etc., or a combination of ports. For PoE side, we're now moving into the 90 watt space. That's also called Ultra PoE. So just be careful. There are switches that have those. Typically right now, the industry, because of cost of the power supplies, etc., or the need of a 90 watt PoE injection is less common. Typical switches will have kind of a mixture of them. So some of the ports might be 90 watt capable, and then the rest of them are 60 watt capable, for example. But they're all backwards compatible, so they can go back to 30 watts or 15.4 watts, depending on what you need. Now, these are classifications. So these are the device classifications. Just keep that in mind, because that's going to something that will affect how we do our PoE budgeting differently from a competitor that allows for us to actually power up more devices. So just keep that in mind. Also keep in mind that even though the technology says like a 60 watt power, the actual power at the device that's delivered is 51 watts max, because that's kind of like the overhead that it takes to traverse the wire, loss of power over the wire, and depending on distance, etc. So this is what it's rated at, and that's important when you're trying to decide what could be powered by the PoE based on the power draw that the device is actually using. So you might want to check. Zyxel does publicize or publish in our data sheets, like I think the power draw of the devices, so it helps you with the budgeting part of your PoE. But that's why some of the other vendors just use classification. They'll just say, oh, it's 30 watts, so we'll just say 30 watts of power. And that becomes a little bit of importance when you're trying to maximize the power and maximize the cost. Minimize the cost, but maximize the power that you're delivering to your customer. The other thing to keep in mind with switching and 10 gig is making sure you have the right Ethernet cabling. So again, some of the infrastructure that our partners are going in, they're needing to upgrade to a newer technology like Wi-Fi 7. They need to upgrade to a multi-gig, 10 gig, but the Ethernet cable that exists there in that building might be old or older and can't support, something like 10 gig. So if they're trying to do 10 gig and they only have Cat 5e, then that could be a potential issue for you. You'll see that it can only push 500 gigs. 5 gigs at 100 meters, right? So that's the length of Ethernet that you can go on a standard Ethernet link max. But if you're using Cat 6, you can do 10 gigs up to 55 meters. But then if you want to go to 100 meters with 10 gig, then you have to use the Cat 6A cabling. So keep that in mind as you are, either testing or checking what's existing in a network when you're trying to do the network refresh to make sure there's no gotchas in the quote when you're quoting out and trying to build out a solution for your customers, that you also take that in mind. Not only is it the hardware piece, but also the wiring and cabling could affect what you're trying to deliver to your customer. Of course, that adds into that quote and adds into the cost, but you don't want to run into a situation where you forgot about that and said, oops, and the customer says, well, you quoted me this, you need to run me that cable to support this, right? So we don't want that to happen. So just keep that in mind. And so it's just a little bit of tips, I guess you can say, just from learning experience. We also carry a full range of transceivers, especially in the 10 gig space. You have to more worry about if you're going longer distances, or you're doing easy uplinks. Most of the uplinks are 10 gig fiber connections. So we do make it easier for you by using a direct attach cable. So that's what the DAC is, direct attach cable. This is for 10 gig, and they come in 1 meter and 3 meters. So it's perfect for like a rack. If you need to go from like top of the rack to the bottom of the rack, even 1 meter is, 3 feet is probably more than enough. It just depends on how you're running the cable. But the great thing is that they're pre-made, pre-terminated fiber connection transceivers. And in some cases, it's actually kind of more cost effective to just get this direct attached cable than to buy the transceivers on its own and then make your own, cabling, et cetera, and make sure that's terminated correctly. So it's a lot more effort. This becomes plug and play. So it's really easy for you to use. You'll, take where your transceivers, and they're also optimized for that length. So you're not buying an optic that is made for, 550 meters and you're only going 3 feet, right? You probably will burn out the transceiver a lot quicker than you would normally, just because of the way that it works in that fiber there. So buy these direct attach cables. We do have the 10 gig versions. We just launched our 25 gig and 100 gig direct attach cables as well. Again, they're more cost effective for you to do uplinking between fiber switches, like on a rack in itself. Now, of course, if you're doing applications like in a hospitality or in a hospital type where you have to go to different demarcation rooms, then you would have to run fiber and get the proper transceivers to run that fiber between those two connections. So it just depends on how you're doing, your application. But just know that we do have these solutions for you, and they're very cost effective, very aggressive in pricing. Now, kind of more into the meat of multi-gig and more the topic at hand. I know I've introduced, some things, but it kind of just sets the foundation of why you even want to go to multi-gig. And it's the future, and it's driven by, I think, Wi-Fi 7 as well as internet service providers. So businesses themselves need to find a way. Everything is moving into the cloud. Everything is dependent upon internet traffic. Can you imagine today if you only had 50 megabits per second, right? And that was kind of a business line not too long ago, when we were all using like DSL and VDSL, right? 50 to maybe 100 megs if you were lucky. Gigabit was it was a rare thing for you to be able to get a fiber gigabit connection to your home or to your business. But that's with, government subsidies and the push to get everyone connected. There is that constant push to speed, right? And even internet service providers are trying to find, well, what is the next iteration that I can provide to my customers so that I can win the business over. So before, if you have a service provider who can only offer 500 megs, and now in that same space, another provider provides a gigabit connection for similar price or for really good price, most likely people will jump to that, even if they don't really use that full gigabit to kind of the full capacity, right? In most of our homes today, we probably have 400 or 500 megabits, depending on if you're using cable service or if you are on a fiber, then you do get gigabit connectivity. But it's probably more than what you would ever need really at home. It helps with the downloads when you actually are downloading something large, like a game or things like that. But in normal day-to-day use, you probably never even do that. Never even have to utilize even a small percentage of that bandwidth. And the same happens in the business. There's a lot of idle time. And so, but that push is, how do I get to that next marketing level? Do I get a competitive advantage now that I can offer 1 gig over people who only offers megabits per second? I can offer gigabit per second, or now 2.5 gig or 5 gig, or now even 10 gig connectivity. If they're already running a fiber line, it's a matter of just changing the transceivers to operate in all the way up to a 10 gig space. So you can imagine for service providers, that's a big push to try to have that infrastructure in place so I can turn up all these intermediate speeds. I can go to the 2.5. I can throttle to a 4. I can throttle it to a 5. Or I can offer that full range of 10 gig connectivity. But that also introduces the fact that the local area network, the customer's business prem network infrastructure, in order to facilitate anything above a gigabit, they need then multi-gig or 10 gig connectivity. And if they have anything that's multi-gig, your backbone most likely should be or is recommended to be a 10 gig backbone, because you don't want the 2.5 gig connections to now bottleneck to, a bunch of 2.5 gigs trying to share a 2.5 gig uplink, right? Or even worse is like it finally gets out to the internet and it gets throttled down to 1 gig, right? So it's not fully taking advantage of the full bandwidth that might be available from the service provider. And of course, then the service provider would have to offer a router, or you'd have to get a router that supports up to that 2.5 gig or 10 gig space. So that expansion now pushes us into our XMG 2230 series models switches and our XS 1935. So again, XMG is the multi-gig switch, and the XS is our 10 gig, like aggregation type switches. And it's made for them, to scale with that service provider, providing these different types of services out to that customer. And then on top of that, not only is the Wi-Fi needing more bandwidth, but then there's a lot of applications that require higher power. So before you had your Wi-Fi 6, they were 30 watt power. Alarm systems, phones were great, and some pan tilt zoom cameras, RFID readers, they only needed like 30 watts of power. But now you introduced a whole new layer of applications that are more power hungry and require a larger PoE classification budget. So Wi-Fi 7 access points, like I mentioned, other pan tilt zoom cameras that have infrared or heaters and things like that require a larger power budget. Laptop computers as just a terminal, so you don't have to have like a DC power connector to it. You can run that off that. Different access controls or POS readers that are powered by that need that power, or nursing call stations, or even information kiosks. Imagine now, you have a tablet machine or like a Windows screen that has like a operating system built into it. You can run it to a digital signage or information kiosk without having to deploy or find a plug. So they literally can be deployed anywhere in that application zone. So not only, again, is there a bandwidth need from a Wi-Fi 7 perspective, but then also, or from a service provider perspective, but then also these different applications need that extra power that some of these new switches will provide. So it becomes not only providing the Wi-Fi piece, but then the backbone of your infrastructure. You have to facilitate that maximum performance. Otherwise, you might as well just buy Wi-Fi 6, run it on the existing infrastructure, lower PoE budgets, and suffer on the 2.4 and 5 gigahertz range, right? From a signal perspective and from an interference perspective. But we want to make sure we get to something like Wi-Fi 7 and take advantage of everything and maximize the performance that's available. So that's where, again, that XS1935 or XMG2230 series switches can support that. Supporting up to 90 watts, has also power budgets, like on our XMG2230, the 48 port version, has up to 2400 watts of PoE power that you can inject if you're using a DC power connection. And the PoE++ is also backwards compatible, like I mentioned before. And these are perfect for applications in healthcare, in campus, and hospitality. We do a lot of senior living facilities, public guest access, even wanting to have Wi-Fi 7 and minimize interference, IP surveillance, esports arenas and esports connectivity, wanting the lowest latency, but then also have the ability to move around and roam if necessary. And then network AV for a lot of those different applications. So using for Wi-Fi, sending a video, voice, signaling through the switch network, etc., making sure that those are all facilitated properly in that space. So again, those applications can be very important, maybe in your business, but making sure that in infrastructure, as they move forward with the technology like Wi-Fi 7 or some of those other applications that I mentioned, that the network is facilitated, the infrastructure can facilitate that application. And the big piece too, another component is once you've deployed these kind of products, how do you manage them? How do you make sure that if you deployed, in a hospital or healthcare environment, you've deployed, 100 of these switches, how do you make sure that they're all up to date? How do you get visibility? How do you troubleshoot? That's where our Nebula Control Center comes into play, because all of our switch products, all of our 10G fiber products on the Zyxel network side includes Nebula functionality. So you can use Nebula Cloud for free, or some of them come with the Pro license already built in for 1 year. And that gives you some additional AI functionality as well as 365 days of logs. You have full auto provisioning functions. If you want to learn more about Nebula, we do run monthly Nebula webinars that talk about the key kind of functions and the key differentiators and selling points of it. And we believe that a Nebula is one of the biggest selling points of our product line, because it becomes that central place that MSPs or ISPs or IT managers can manage and see visibility in the network like never before. It is a network admin's dream to have this kind of interface, and the fact that a very high percentage of the functionality is for free makes it even better. But as an MSP or as an ISP, you're going to want to subscribe to the full, full-fledged pro version of this, because it does give you a lot of benefits from a management, cloning, kind of auto provisioning cloning's functionality that helps you on your day-to-day, but then also onboarding new customers. And you can manage it all from that single pane of glass, multiple customers. So again, if you want to learn more, please feel free to join that webinar when we have it every month. We also pride in the quality of our product design on the switch side as well. We do typically have larger operating temperatures. We do have a ruggedized switch line that does support even extended range in those thermals. We just launched our industrial Wi-Fi access point for Wi-Fi 7 that are DIN rail mounted, and then they also have PoE power, and it's also temperature hardened as well. Lower smart fans to help with the noise if they do have fans. Many of our models are fanless, so they can operate without noise, and so those are great for certain applications, audio video applications that need the high bandwidth, but then also need it to be a little quieter. But even in most cases, the fan can throttle down as traffic is not being pushed very heavily, so it can move relative to, or it can be, relative to what is being used. Power noise filters to make sure that the system is stable. And then most importantly is the solid state capacitor. Solid state capacitors, because they, instead of using the saltwater capacitors that can burst and cause issues in functionality, these are highly stable and robust, and that's where we pride in the very large mean time between failures of these products based on the components that we use. Now, I did allude to some of that smart PoE functionality, and I wanted to kind of give you an example of what I mean by how Zyxel does their PoE differently. So we have classification mode. Let's say your typical handset phone probably is classified to use that 15.4 watts of power. So they're classified in that class 3 space, but actual utilization, let's say, of this device is only 9 watts. In a competitor product that uses classification mode, in order to power up 24 phones that use this in that classification mode, they're going to need 370 watts of PoE power budget, versus a switch that uses what we call consumption mode, which we call it smart PoE. Then it only puts the 9 watts against the budget. So in this case, you would only need 216 watts to power it up. Well, you say, well, the switch has 375 watts, so it works in both cases. Yes. But what if you had something that used more PoE power? For example, a IP camera. Let's say this is classified as a 30 watt, so it's a class 4 PoE device. In classification mode, as their competitors, in order to power up 20 of these devices, you would need 600 watts of PoE budget. But with Zyxel's, let's say the camera only consumes 16 watts of power, and that's pretty standard for an IP camera with this kind of pan, tilt, zoom kind of functions. Then we only need 320 watts in our budget to power up the same 20 devices. So I always say we have a smart PoE that can power up more products or more devices in the same budget that we offer today. So not only is it going to be more cost effective, but then it also maximizes the PoE budget. So in the end of the day, you're not running a larger, you're not buying for a larger PoE power budget than you actually need. Our switching also has a lot of the key features that you would typically want in a switch network, like VLAN, voice-based VLAN based. You can set that up as well, so it can auto detect that and move those kinds of traffic or handset devices into those VLANs automatically. It can automatically detect and recover PoE devices. So let's say you have an access point or an IP camera that stops communicating, then you can actually have the system automatically try to recover the device by rebooting that PoE port for you. And the intelligent PoE I mentioned before already, also specific CCTV and IPTV broadcasting reporting tools. And it also helps by identifying machine learning in the cloud, any kind of blocking or broadcasting, and making some auto corrections to those networks as necessary. It helps to also visualize the network within our Nebula platform. You can look at the topology, you can manage the virtual switch stack there, and you can see the devices that are connected to the switch. You can drill in, drill through, so you can manage it from the AP side, drill into what port it's connected to on the Ethernet switch, and see information there, get real port utilization information, as well as diagnostic tools and fiber connection testing tools as well. It also gives you security from a cloud backup to restore configurations. You can add port and user security using authentication and manageable in the cloud. Also network protection, including things like LoopGuard or DHCP guard. That is prominent in many cases. You probably have, I don't know how many of you have gone to a network, whether it be a school network or an office network, and seeing a lot of open Ethernet ports and plugging a device into it, like your laptop, and getting an actual DHCP or actually getting connectivity when you shouldn't. Or the fact that you potentially could put a router and connect the LAN into that network and cause potential DHCP havoc, right, into that network without realizing. Maybe it wasn't intentional, but all of a sudden there's another DHCP device on there giving out IPs that don't make sense to that network and causing a lot of issues there. Not that I've had experience with that, but we've had a lot of experience with that. So DHCP guard helps to block that. So it only allows for DHCP replies and requests to replies to come from a specific port, which is your router or your DHCP server, whatever it may be. So it helps to improve all those kinds of functions and things to, from a security perspective. And because it's like backup and restore, you can speed up deployments. You can do a lot of break fixes and changes easily. You can create switch templates, then you can synchronize settings between switches. Or you can imagine if the hotel environment, all the switches are pretty much set up identical. They have all the same VLANs. They have all the same uplink ports, etc., and rules, etc. You can make that your general site configuration, and within Nebula, all those switches that are added to that network inherit those policies or those rules for themselves. So it allows for you to do stuff very quickly and very easily. Now, from specific products, we have a lot of ones that support the multi-gig and 10 gig. So a 30-watt PoE injector, so it injects both power and delivers the data at 2.5 gigs and 30 watts. You can do 5 gigs on a 60-watt injector. And then we have a newer model that is a 90-watt that can do 10 gig connectivity. So it's also for any kind of PoE injection for certain applications. So our XGS 2220, it's a gigabit switch, but then has 10 gig uplinks. So I know I talked about imports and multi-gig, but we do have options that can still establish the gigabit connectivity as well as then give you 10 gigs for the core to make sure that you don't oversaturate the ports. But then our entry-level XMG that's manageable in our Nebula Cloud is our multi-gig 1915 series. So these are their like 8-port and 16-port kind of flavors that give you 10 gig uplinks, but then multi-gig ports. The ports that have the little orange band, those are the ones that have the PoE power. And in this particular case, these are the ones that give you the 60-watt power on those ports. But then they're primarily at like 2.5 gig ports with 10 gig uplinks. So that's very cost effective if you're looking for a multi-gig small port count to just enhance the existing business networks. And then you move to our XS 1935 series. These are our layer 3 upgradable managed, web managed and cloud managed switches. They're also multi-gig ports, but can support in this new 1935 series up to 90 watts of PoE power. And the power budget's also increased on that 12 HP to now 400 watts. And they are Nebula capable, like I mentioned. And then they also allow for very silent operations. I think some of them do. I think the non-PoE versions are fanless. So those are very quiet, obviously. But then they give you then the 10 gig uplinks in this flavor. Our XMG 2230 series is our new model that we just launched. It has our full layer 3 access and stacking functions, as well as very large PoE budgets. So we have a 24 port version. We call it the 28 HP, and then a 48 port version, which is the 52 HP. Now you might ask, well, why is it like 28? What does 28 mean? It means there's 24 ports plus 4 uplinks. So then it adds, so it becomes a 28. And the same thing for the 52. There's 48 ports of ports with 4 uplinks. So that's how we name our, kind of a port configuration. And it's XMG, so these are all multi-gig. Now, something special about these ones, they do have kind of a split on the 52. This one, they're all multi-gig with, the full power. On the 52 HP, there's kind of a mixed network. So there's a split. There's 16 ports that are 2.5 gigs, and then the other ones are gigabit. So it's kind of a interesting mix there for for this particular model, because it's more of like a hybrid network switch. So just keep in mind that if you do need all ports 2.5 gig on a 48 space, like a 48 port, then you might want to look at getting two 28 HP models to facilitate that. But if you do have a mixed network today, because you're transitioning between both gigabit and multi-gig, then this is also, it's cost effective, but it also gives you a very high power budget. You can see it's 960 watts if you're using the AC connector. They come with both AC and DC in the back. But if you juice it as well to provide backup power, then it can actually go up to 2400 watts on all these ports. So just keep that in mind as you're speccing it out. So it follows similar to some of our competitors that do that as well. Eventually, there will be kind of a full 48 port, all 2.5 gig type. But right now, the chipset that's supported is in this kind of configuration. Now, if you're looking for more of an access, kind of top of the rack access type switch or an aggregation switch, then our XS3800 is good for that. They're all 10 gig ports, so 10 gig fiber transceivers, a couple of dedicated copper, and then these ones on this side are combo ports. So whether you get to choose if you want to use the copper on this one or the fiber, the copper one here or the fiber. So you could choose only one or the other when you're using them. You can't use both at once on those combo ports, but it lets you flip between more copper or more fiber depending on your application needs. And they're all 10 gig and can do layer 2, layer 3 routing functions. So that's great for that. And then we just launched I call it our beast, our new CX4800. This is an aggregation fiber switch that gives you 25 gig ports as well as 100 gig uplinks. So it boasts 48 ports of 10/25 gig SFP28s. They're pre-configured for 10 gig just by default. And then you can flip them to become 25 gigs. And then it also has 8 100 gig QSFP28s. So now you can do link aggregation. So you can have lots of hundreds of gigs of uplinks if you need. So you can even go 400 gigs to another switch, 400 gigs to another switch, 400 gigs, and then make a ring topology back down to the first one at 400 gigs if you wanted to. So it's quite a large capacity product. It has hot swappable fans and hot swappable power. It's also cloud manageable in our Nebula platform. And then we'll be adding our layer 3 aggregation and stacking. It already has some basic L3 features, but then there's additional stacking and other routing type features that we're going to be adding soon for that. So many applications that it could be used for, obviously in an office environment where you're needing multi-gig, maximizing the performance, trying to move the bandwidth through. One of the big applications that I have is even though there might be cloud storage, typically there still is a local file share or local storage backup that maybe the devices are backing up to first, and then it gets sent to the cloud later on. But that could be beneficial if you're using Wi-Fi 7 to maximize that bandwidth to get to 10 gig connectivity on a Wi-Fi level, so that when you're doing that kind of backup, it happens much quicker than if you were stuck on a gigabit or less than gigabit connectivity. Because if you think about it, Wi-Fi 6, you're going to max out in most cases at like 4 to maybe 500 megabits per second, because the technology in itself can't push more than that, unless you've opened up the signal pipe, but then you've used the entire bandwidth, and it's going to cause all interference, or any kind of other Wi-Fi is going to cause interference to it. So it's going to not really work very well. So you're not going to still get that full bandwidth that you were expecting that you would typically. So Wi-Fi 7 does open up that door that you go beyond that gigabit to closer to 10 gig connectivity. And then so that way your backups, or even the file shares, or applications like in the hospital where maybe the X-ray imaging is being downloaded or looked at from a different department in the building, and they need to open up that file. so that the whole network being 10 gig or more will help facilitate that transfer or access to that file. And then in bigger offices as well, if you're doing like IPTV or things like that, then you can aggregate it with a lot more 10 gig, multi-gig type switches, etc. I did mention some of those applications earlier, like we do in like healthcare and hospitality, etc. So if you'd like to learn more about those applications or look at our case studies, we do have a kind of extensive case study site on our webpage. You can search for those different verticals and see some of the things that we've done around the world and the products that were utilized in that. But then if you also want to connect with us on LinkedIn, it's Zyxel-US-channel. Or if you want to watch this video and other videos that we record for our webinars, you can find them at Zyxel America channel. If you want to connect with me, you can search for me on LinkedIn. I'd love to connect with you. Just search for Zyxel Tri, so TRI, and you'll find us as well. If you're looking at wanting to sell our products or interested in some of that, please reach out to your sales managers, account managers, your reps there. We're here at Zyxel, and we'd love to make sure you get the information that you need and help you with any way that you might need from a pre-sales or even post-sales support. And we work through a lot of different distributors. If you are working in the Zyxel network side, or again, work with your channel account manager if you're in the Zyxel communication side of the business. But if you have any questions, here's your chance. I didn't see any questions during the webinar, which is fine. But if you have any questions now, you feel free to ask those using the Q&A section. But if you don't think of anything right now, but maybe something comes up a little bit later, you can just email me direct if you like, try@zyxel.com. Yeah, that's it, TRI@zyxel.com. I've been at Zyxel so long that I get a three-letter email. So it makes it easy to remember. No try dot last name, nothing like that. It's just TRI@zyxel.com. We'll be at Fiber Connect next week. I will be there. If you happen to be there at Fiber Connect or want to stop in our booth and say hello, just look for the guy with the blue hair, and we'll be standing there at the booth. And feel free to talk to us, have a conversation. We'd love to meet you and greet you in any way we can. But then there's a lot of other shows that we're going to as well. We'll be at IdeaCom also next week. I won't be there next week, but some of our other representatives will be there. But I will be at Fiber Connect. And also in a few weeks after that, about a month from now, I will also be at Infocom in Vegas. So if you are going to Infocom as well and want to set up a meeting or set up anything that you want to talk with me and Zyxel about, we'd love to connect. So feel free to reach out. Just send me an email and say, hey, I'm going there. How do I connect with you? And we can work through that. But if you don't have any questions right now and you'd like to drop off, and thank you very much for joining this afternoon, almost afternoon, I'll give you back your 12 minutes to the top of the hour. And hope you have a great rest of your day, and hope we interact sometime again soon. Look forward to talking to you and seeing how Zyxel can be your networking ally and work with you in providing network solutions to your customers. So make sure you look into getting multi-gig and 10 gig into your networks and customers. And hopefully this has been something helpful for you. I look forward to talking to you again soon. Have a good rest of your day. Goodbye.